My name is Bailey Brashears, and today I'm going to be talking about my project, The Effects of Feature Verbalizability on Category. Before I get into the project itself, I'd briefly like to talk about the COVIS theory of category learning. COVIS stands for competition between verbal and implicit systems, and this is basically a theory that says that there are two separate but competing systems that we use to learn different kinds of categories. The first is the verbal category learning system, which is based on easily verbalized rules. This can be things like red items belong in group A, while blue items belong in group B, or it can be more complex, consists of series of rules, things like that. This system is consciously used. It operates through hypothesis testing, revising those hypotheses, things like that. And previous research has found a bias towards this system on experimental categorization tasks. Basically, if someone is expecting to be doing a categorization task, they're more likely to use that hypothesis testing, and so they'll be doing verbal category learning. The second system is known as the implicit category learning system. These two systems are in competition, so they're both functioning at any given time, but it's more likely to see implicit category learning after the verbal category learning has already failed to come up with a sufficient rule, because implicit category learning is a much slower system. So this can be used to learn things like family resemblance, where groups of items share some features, but there's not necessarily any one feature that's perfectly predictive of category membership, information integration, things like that. The system is automatically used. It's gradually learning these associations over time, as opposed to the verbal category learning system. And this is used to learn most complex real-world categories. So when I came up with the current experiment, I was thinking about this COVIS theory, and thinking about how verbal systems, the verbal system uses rules that can be described verbally. So we would think it would follow that if the features are easy to name, then it's easier to form those verbal rules. So my hypothesis was, if an object has features that are easy to describe verbally, then they'll be easier to form rules for classification, and therefore we would see more of that rule-based learning when the features are easier to verbalize. When I began this experiment, there was no other research on this I could find, but there has been some other research that parallels this that has come out during the process, and I will talk about that just a little bit at the end. So to start this process, I made these stimuli that you can see here. They were made up of 5 binary features that we brought together to make one stimulus. So the first set I made was the Easily-Verbalizable set, which you can see here. So we first had, 5 feature pairs, the first of which were 2 versus 4 spots. Then we had 2 versus 3 eyes, blue versus orange ears, square versus triangular tail, and red versus green hair or back fat pattern, whatever you want to call it. So as you can see here, the contrasts are all primary colors. There's numbers of things. It's all very easy to describe in 1 or 2 words. To verify this, we did run a brief norming study where we asked subjects to name the features, both of this and the not easily verbalizable stimulus that I'll show you later. And we did find that these features were easier to name than the features I'll show you a little later. So to make the actual category set, we would take the group A prototype with all the group A features, as well as varying one feature, so adding one B feature to each of the to the A prototype. We also would disclude one of the features so that one feature would always be perfectly predictive. In this case, it's the number of spots, but in the actual experiment itself, this was randomized, so it could be any of the features. The reason for doing this was so that the categories could be learned either by family resemblance. As you can see, there's a general overall look to the group A stimulus, but could also be learned using rule-based learning with that perfectly predictive feature. So you could say all group A's have 2 spots, and as you can see with the group B here, all group B's have 4 spots. So that's a big part of building the stimulus set, is that they could be learned either by category or either by family resemblance or rule-based learning. I then made the ones with features that were not easily verbalizable. And while these could be described verbally, the idea is generally that it's a little more difficult to describe the difference between them. We don't necessarily have readily available words for them. So we have differences in the spot patterns here, difference in the shape and orientation of the eyes, in the shape and size of the ears, as well as the nose, and differences in the pattern on its back. The category sets were then built using the same logic as the easily verbalizable set, with a general family resemblance and one perfectly predictive feature. Again, for illustrative purposes, it's the spot pattern here, but in the experiment itself, it could be any of the available features. Here we have same thing for group B, family resemblance, and perfectly predictive trait. So the experiment itself was built in a video game that I designed using a program called Game Maker 2. So subjects were brought in and were shown this screen, which explained how the game worked, and that they would be sorting these monsters that I had made into groups, into group A or group B. So they would see something like this. Each subject was randomly assigned either the easily verbalizable or the not easily verbalizable stimulus. They only saw one of those sets. So they would see a screen like this. Here with the easily verbalizable stimulus, they would choose a caller with either an A or a B corresponding to the group. And then they would put the caller on the monster and receive feedback. In this case, the category decision was correct. So, like I said, subjects were introduced to the experiment this way, and they needed to complete at least 60 trials just to ensure that they've seen all the different variations of the stimulus. And after that point, they had to complete 12 trials in a row correctly, and then they would move on to the testing phase. If they failed to do this in under 400 trials or within an hour, the experiment ended, and we no longer used their data. For this particular experiment, this only happened with 2 of our subjects, 1 in each condition. So moving on to, when they move on to the testing phase, they would see 3 different kinds of stimulus here, and this time they would make their decision without feedback. They would see the 10 different variations of the stimulus from the training phase. They would see each of the single features in isolation, and they would also see 10 conflict items, which I will discuss more later in the presentation. So the first thing we looked at in terms of results was the number of trials it took to reach that criteria and move on to the testing phase. So we found that there was no significant difference between the easily verbalizable and the not easily verbalizable groups here. It took about the same amount of trials for subjects to learn each of these stimuli. They were about equally easy to learn. It is worth noting that there was a minimum of 60 trials here, which is why the minimum number of trials is so high. So it is possible that subjects could have learned it in under those 60 trials. The next thing we looked at was the accuracy, looking at the training items presented again during the test phase. And here we did see a significant difference. For the easily verbalizable condition, the subjects were significantly more accurate in categorizing these training items that they had previously learned, which means that the easily verbalizable stimulus were just a little bit easier to remember, to hold in their memory than the not easily verbalizable stimulus, since we know they've learned in both conditions, they were able to learn the category membership. So the next part of the analysis has to do with the conflict items. As I previously mentioned, COVIS, an important aspect of COVIS is that these 2 systems are in competition. So the way that we determined what the strategy use was through use of these conflict items. So this is an example of the conflict item here. Here we have all group A features except for that perfectly predictive feature. Again, it's 4 spots here, but it would be changed to match whatever the particular feature was for that experiment. So as you can see, the perfectly predictive feature is in line with group B, but the family resemblance is in line with group A. So if a subject was using that family resemblance strategy, we would expect them to attend to the overall appearance of the stimulus and classify this as a group A. Whereas if they were using a rule-based strategy and only attending to, again, that feature that was perfectly predicted in the test phase, they would only pay attention to the number of spots and then classify it as group B. So using that as a template, we determined what the responses for each test item would be based on each potential strategy. And then we would take the results of our subjects, for example, this pattern of results here, and we would just compare it to those 2 template responses and assign each subject a score, 2 different scores, a family resemblance score and a rule-based score based on their responses. So that's how we determined the strategy that they were using for this experiment. So we then graphed all those numbers here for each subject. Sorry, there was no main effective condition, but a main effect of model as well as an interaction. So I'm going to discuss what that means. First, looking at the not easily verbalizable results, you can see there was no clear preference for either strategy. Subjects were using both rule-based and family resemblance about the same. There was no clear pattern to it. But for the easily verbalizable subjects, we saw much more use of that rule-based strategy and much less family resemblance strategy use. So from these results, it does seem that the subjects were more likely to use rule-based strategies when the features were easy to verbalize. This is, of course, in line with my hypothesis, and so we were able to show that feature verbalizability does seem to facilitate rule-based strategy use. Moving forward, we're currently working on an online replication with a larger sample. Because of the COVID situation, naturally, we're having to move everything online, but this will also let us test a lot more subjects. In addition, as I previously mentioned, there was some related work that had come out while I was working on this project, and that happened to be from Zetterstein and Lupian, who did a similar project to mine with uses of color as well as shapes. And for this new experiment, I've built a new category set. You can see the easily verbalizable stimulus on the left and the not easily verbalizable on the right. These new stimulus sets have the same underlying logic, but have 3 shape contrasts as well as 2 color contrasts. These color contrasts were taken directly from the Zetterstein and Lupian paper, and they've been rigorously tested for their nameability to ensure that the not easily verbalizable group is truly not easy to verbalize. I'd like to thank my advisor, Dr. John Paul Minda, and the rest of the categorization lab at the University of Western Ontario. If you're interested in our work, you can find us online at mindalab.com. Thank you so much for your time.